Lesson 6-5, Applying Systems, also known as Word Problems. You are going to need your Know It Note, page 86. We're going to write a few things down and then do 3 problems together, those 3 problems that I gave you a copy of in class. One reason we want to try to write systems of equations for word problems when we're looking for 2 things is that it can often make writing the equations a lot simpler. And so the 2 main questions you want to answer, and you don't have to write all this down, this is just think about it kind of stuff, is what are those 2 unknowns and what 2 equations can I put together with the information in the problem. So we're always looking to write 2 equations with our 2 unknowns. So I have some steps for you. Wow, crazy computer. And write these down. You don't have to write every single word down. You are going to need some binder paper eventually because you'll never be able to get everything on the page. So either do it at the bottom or up near the top somewhere and then find a piece of binder paper for later. First of all, read the problem carefully. Maybe even read it twice. Okay. Step 2, identify each variable. Write them down. What are you going to use, right? I'm going to use F equals the felt sheets. Right? I'm going to use C equals the cardstock sheets, so you know which one's which, especially if you choose to use X and Y, because otherwise you're not going to know which one stood for which thing when you're all done. Okay? If you have a trouble figuring out those variables, look at the question at the end that says, how many packages of hamburger buns and how many packages of hot dog buns are they going to bring? That means we must be looking for hamburger buns and hot dog buns. Then write 2 equations based on the problem information. Sometimes you might need a formula like distance equals rate times time. You can make a chart to keep track of the information. I'll show you how to make a chart for mixture value problems. Step 4, solve with elimination or substitution. You could solve with graphing also, but it doesn't always work so well for word problems because the answers are often large, which makes it hard for you to graph graph far enough to find that answer. And then write the word answer. Make sure it's reasonable. Okay, so we shouldn't get -10 packages of hot dog buns. That means you made a mistake. If you need to pause this to finish writing it down, go ahead and pause it. We're going to try a few. So here's the first one. This is the rate example that you have. And we're going to make a chart to keep track of things. It takes Kathy 1.5 hours to paddle her canoe 6 miles upstream. Then she turns her canoe around and paddles 6 miles downstream in 1 hour. What is the rate of the current? Remember, the current is the rate that the water flows, by itself because it's heading downhill toward bigger rivers and eventually the ocean. So when you're going upstream, you're going slower because the river is going past you and it's trying to pull you downstream. When you're going downstream, you get to go faster because the current is helping you as you paddle. Okay. So what is the rate of the current and what is Kathy's rate of paddling in still water? Okay, so we're going to think about this. So we need, we're going to make 2 equations and we can use the distance formula. Now we're going to look at how fast she goes upstream and how fast she goes downstream. Okay. How do I know that part? Well, some of this comes from practice. Okay, so when I have these problems about distance, rate, and time, I usually want to try to set up 2 equations, one going with the current or with the wind if we're talking about an airplane flying into the wind and against the wind. So I want to set up one for each of those. Now I know the time it takes her to paddle upstream, so I'm going to fill that in, 1.5 hours. And I know the distance, she goes 6 miles, right? I don't know the rate. Okay. Let's leave that there for a moment. We'll fill it in, right? Then she turns her canoe around. She paddles 6 miles downstream in 1 hour. Okay. The 2 things that we're being asked are the rate of the current. So that has to be one of my variables. And we're being asked for her rate of paddling. So let's call that P. And since we have some blank spots, presumably those variables are going to need to go into the blanks. Okay. The rate of the current affects her overall rate. when she's going upstream, now remember upstream means she's going against the current, so she's going slower than she is actually paddling, right? Like if she could paddle, say 10 miles an hour, but the current is going against her at 2 miles an hour, she's really only going 8 miles an hour upstream. So we're going to take the rate of paddling and we're going to subtract the rate of the current because it makes her go slower. Right, so we got to take that off. It slows her rate of paddling down. Now, when she goes downstream, it's like she's zooming. If she keeps paddling at the same rate along with the current, it makes her go even faster. So we get to add that current on. Okay. Now, the one thing that we left off here is that, right, distance equals rate times time. So let's write our two equations here. 6 equals 1.5 times P minus C, and 6 equals 1 times P plus C. That's my system of equations. And now I'm going to solve them. And I think I have room, I think I have a blank slide on the next one so I can continue because that's not going to be enough space. Okay, so 6 equals 1.5 times P minus C, and 6 equals 1 times P plus C. So let's go ahead and distribute, and I get 6 equals 1.5 P minus 1.5 C, and 6 equals P plus C. Now I can use substitution or I can use elimination. For me this time, just because I'm going to choose substitution. If you prefer elimination, go for it. So I'm going to subtract C from both sides and get 6 minus C equals P. And I'm going to plug that in for P. I'm going to change colors. It's a little easier to see what I'm doing. So I'm going to take P in my first equation and I'm going to replace it with 6 minus C. And that gives me 6 equals 1.5 times 6 minus C minus 1.5C. It's okay also to have multiplied by 10 to get rid of the decimals if you prefer. A lot of options here. 1.5 times 6 is 9 minus 1.5C minus 1.5C. Let's zippity zap. And we get 6 equals 9 plus negative 3C. Subtract 9 from each side. And we get negative 3 equals negative 3C. So the current is going at 1 mile per hour. I don't think we were talking about kilometers. I think we're talking about miles. Plug that back in, and we know that 6 minus 1, 6 minus C equals P, so 6 minus 1. So that means she's paddling at a rate of 5 miles per hour. Word problem, word answer. The rate of the current is 1 mile per hour. And her rate of paddling is 5 miles per hour. Okay. 1 down, 2 to go.